then how about 1, 8? Okay. Oh, another matrix. Oh, hell. Zero matrix. Write an algorithm such that if an element in an m by n matrix is 0, its entire row and column are set to 0. Okay, I guess that's not too bad. Just anytime you see a 0 on a row or a column, set the entire row and column to 0. So actually, humorously enough, on the very last problem, I did sort of figure out how to rotate a matrix. I never made that connection even when I programmed it just a few minutes ago. But rotating the matrix is the same thing as inverting the matrix? No. This first thing is the same, is inverting the matrix. This second thing was rotating the matrix. If you just do this, you've just inverted. So I'm pretty sure this is really simple because we just need to, basically, any row that ends up with, all right, let's start. All right, so I think we're gonna, hey, it's not what I saved, is it? Oh, it is, okay, yeah. Any row that we're going to end up zeroing out, whatever, let's think about some example test cases. This should return this. This should return this. I think, let's just deal with 3x3s because I don't think we need to go too much further than that, honestly. But this one should return, let's just do a row, a column, and a both. I think that's fine. So this one should return the 0, or wait, which one's the expected is the output, so that should return all zeros if any element in here is 0, right? This should return all zeros if that was the input, wasn't it? Okay, this should return all zeros if any. Oh, you know what? Actually, it should return all zeros like this. I just realized. Oops. Oh man, I really suck at this. All right. So this should return all zeros like this, shouldn't it? I get what they're saying. Yeah. So because there's 1 0 here, this whole thing becomes 0. Because there's 1 0 here, this whole thing and this whole thing becomes 0. What else? Because I guess I don't really feel like we need a third one now. I guess we can try, actually we can have a third one where just test 2, right? Which in this case, if we do any 2, oh, okay, if we do any 2, let's just do 1 in the center. All right, that should return like this and like this. I did it backwards again, didn't I? All right. So which 2 are we going to set? We're going to set, let's say these 2. Let's say these 2. All right. And so that should end up being 0 along this thing, 0 along this thing, 0 here, 0 here, 0 here. Okay. So I think that's a reasonable set of test cases. And then all right. Then what else? Then let's actually try to think about this. Apply map rotate matrix. Okay, it's not rotate matrix anymore. Now it's zero matrix. Get your name right. And you didn't. You did this thing again where you saved it wrong. Here. Okay, chapter 1, problem 8. Rotate matrix. That's CLJ. Okay. Yes. Oh, let's just go into here. We didn't need to make changes to this guy. Okay. All right. So we got some test data, and we got this zero matrix, and we're just gonna change it to zero matrix. And okay. All right. And so, cool. What do we need to do? I think we just need to basically zeros dominate, basically. I wonder if we could do something like a mask or something. No. What's a nice way to do this? I mean, thanks to my little thing I figured out last time, I can build the matrix in both forms, right? In this form, I can. I don't want to say it's inverting the matrix, but I can. Maybe it is. I'm just not clear about that. But I can flip the rows and the columns in the matrix. Let's say that, with that guy right there. So if I can do that, I can view them both from their columnar point of view and from the row point of view. And then I can, when I flip the rows to columns, I can then do something on them, and then I can rotate them back to columns to rows by flipping them again, So all I need is a function that maps across a matrix, right? Converting any row with a 0 in it into a row of all zeros. So it sounds like first of all, we need just to be able to ask the question, contain 0, I guess, right? It just takes a sequence, and it will say is I know it makes sense to use sum, but I don't really get it a lot of the time. So I'll use this one actually. Yeah, that's actually better anyway. So this contains 0, right? And okay, if it contains 0, then I should make the whole row 0, right? Right, so I should take the sequence, and I should map over the sequence, and I am completely ignoring, I'll make that explicit by doing this, completely ignoring the actual value, and I'm just returning 0, right? It's kind of a dumb function, but there you go. And if it doesn't contain 0, I'm just going to return the actual sequence. So I'm going to just call this one 0, phi row, 0, phi row, right? Takes a sequence, and if the sequence contains a 0, then I'm going to 0 all on the sequence. Otherwise, I'm just going to return the sequence. Okay. So now I got a thing that I can take a sequence, and if any item in the sequence is a 0, I'm going to change it to the entire sequence to 0, to all zeros. Okay. All right. So now that I got that, I just need to do it in 2 separate ways. trying to think about it. Okay, so if a zero shows up, let's go through the first way, which is it shows up in the row already, right? That's, I think, a little bit easier. But so we're ignoring this for now. We're ignoring this for now. But if it shows up in the row at all, right? I should just be able to call this, right? And it should just, now all the rows should be zeroed out, right? But not all the columns, unfortunately, yet. Okay, so let's see about that. And that's the previous one. Wait, that's not right either. Did I give it the wrong name? Yeah, I did. Okay, XS, XW. It's chapter 1, problem 8. It is not rotate matrix, it is zero matrix. That's the LJ. I could have done that in a different way, but I didn't, so we'll just close out this one. Alright, okay, so oh, I did it. I also put a dash. Damn it. Okay, last time, chapter 1, problem 8. Alright, I actually forgot, or actually, yeah, that's what I really want to do. How come that doesn't exist as a default binding anymore? Anyway. Do chapter 1, problem 8, zero matrix.clj. Oh, god dang it. I thought you were asking me what to... It's easier to just use dir than this stupid thing. Okay. Alright. I want to rename this. I want to rename... Oh, yeah. Now I say I want to rename... What is... I want to rename... to chapter 1, problem 8, 0 matrix.clj. There we go. Alright, so zero matrix. So if we just zeroify the row, let's see what happens. Get a big error. Okay. Is unique test. Round number of args past equals course sum. Really? Okay, let's see. Sum. That is, yeah, that is not what sum is for. Any, I think may be what I want. I don't remember if there's a question mark there or not. Closure any. Nope, that's not what I meant either. I thought we just looked at one that was like, do I keep closing the cheat sheet? Yeah. Okay, so I could use this one to say if every item is non-zero. I could use this one to say that if every item is... Or I guess I could use this. I want... Okay, so some... Okay, I think maybe not any is actually kind of one of the better ones. There are not any zeros. I think that makes human readable sense. Okay. If there's not any zeros, then... Oh, that's backwards. Yeah, and the not makes it confusing. If there's a not any, whatever. Why is there no not any? Why is there no any in this place? Why is it over there? Huh, weird. But I mean, they strongly want me to use some. I guess I should just return as the first logical true value of for any accent collection. Okay, but so it will actually return the value and not true or false. Is that okay? Yes, the only falsy things in Clojure are nil and false. So even the 0 is okay. Some 0 will return any zeros. The zeros will be true. The 0 all will happen. Okay. Okay. Let's see if it worked at all. 1, 3, 4, 2. Hey. What? You're not supposed to be rotating things. You're not supposed to be doing anything. What? MGS, just make sure we don't have other stuff. No. That's the 8. Why is it rotated? Oh, wait, that's not right at all. Yeah. So this should just be the identity. Okay. All right, one last failure. So 741. So what did it end up being? It's saying that 741-852-963. Oh my gosh, none of these are right, are they? Oh, I just copied them willy-nilly without thinking about what I was copying. Okay. So yeah, it should just be 1, 2, 3, 4, 5, 0. Okay. This should be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and this should just be 1. Sorry, that way. Okay. So are we getting rows at least correct? Yeah, that's actually the distinguishing characteristic is we have entire rows set to 0, but we don't have. Well, that's the input, isn't it? We have entire rows set to 0, but we don't have columns set to 0. Okay, that looks promising, so I'm okay with it. Just for no particular reason, let's actually use map v instead of map so we can just keep the data structure looking the same. Okay. And so then what we need to then do is sort of do that inverting thing we did, which let me see if I can remember how to do it. Apply map vector on that. Right now we're pulling it out. We've just reversed it. So now the rows are columns and the columns are rows. Ooh, you know we can't, because now we've already copied zeros into certain things. Ooh. So if I do it again, it's going to pretty much always span the entire, it will span the entire vector, because there always will be a 0 in the vector in every new row at that point. Okay, so, oh man. Oh man. Interesting. Okay. Yeah, so you sort of got to do them in 2 separate flows, right? And put them together, kind of. Kind of, yeah. I mean, okay. All right, sure. So let's just say 0, 5, or zeroed rows is just going to be the map of 0, 5 rows on the matrix. I guess we can say zeroed columns is going to be the map That's actually just going to be a really crazy thing where it says the map of the, we first weird out the vector and then we weird it out again to put it back the way it was. All right. And then finally the, oh, we don't need any final. That's it. That's it. Yeah. So we now have, I think we have things where all the rows are zeroed out that had a 0 in them. And we now have also a thing that where all the columns are zeroed out where they had a 0 in them. I guess we can just do this for this one. Right? And now we need to sort of put them all together so we can map, I guess just vector, I think. No, we need something a little more complicated than that. X, Y, and Z, right? Come on. I guess just XS, right? It's going to be 3 items. I won't worry about it right now, but I'm just going to say it's the zeroed. I guess we don't actually need the original one because that, so we only need 2 actually, not 3. Zeroed columns, zeroed, alright, I'm going to keep them in the same order. Zeroed rows, zeroed columns. But the interesting thing is if basically it's mapping over each of those. Wait, these. Yeah, it's mapping over each of those. And it's basically saying if either the case that R or C, right? If R is 0 or C is 0. Oh, you know, we don't even need to do that. Super simple, actually. Just do an anonymous function. Say the min of, actually I think that's just it. Just take the min, right? Ooh, let me think about that. So this zeroed rows and 0 columns, they're matrices both. But, so they're a map, a vector of a vector. So the thing that's being passed here is a vector of integers. We don't want that. We actually want apply? No. It's like we want a map within the map, I think, or something like that. Okay, back me up one. Okay. So we want a function that is going to take R1 and R2, right? Row 1 and row 2, right? And yeah, that is definitely what this takes at this moment in time. It just takes, I kind of want to do this, but I don't even quite visually see in my head what that does. Well, it doesn't make sense because it'll expand this one out, but won't expand this one out. So that does not actually make sense. But we do have 2 rows, right? 2 rows. And so what we want to just do is, I think on this one, now we're guaranteed to have 2 vectors here, right? And so I think we do want to do, apply the min on, apply the map of the min on R1 and R2. All right, so we're saying for each item in, so map across R1 and R2, which means you're going to return a vector of a sequence of 2 elements for each call to map. And so we're just going to say, okay, that's interesting. Let's see. Yeah. And let's just make it into a vector just to, and let's make that one into a vector too, just to keep it. Just to keep it. Could not resolve symbol zeroed rows. Zeroed rows. I see. Boom. Is unique test. What the hell? Is unique test. Who the hell is testing that? Wait, who's doing is unique? Oh, I have not been renaming the test every single time, have I? Yeah, oh man. Let's just do that so I stop doing that on mistake. Okay, my mistake. But zero matrix. Alright, what was it complaining about? I was confused about other things. Zero matrix, CLJ23, cannot call with one argument, zero matrix. Okay. Zero matrix looks like it can be called with one argument. Where are you? Line 23. Yeah, okay, so that's just this thing. Sure looks like it can be called with one argument. I mean, I could be mistaken, but travel length is call with one argument. Huh. Alright, well, I'm sorry for you, but why can't you call that with one argument? I just don't see where it's going wrong. Here's a map V. What the heck? Well, I have no real idea about what's going wrong here, so I'm just gonna just see if we can get it not to fail. Okay, so that's pretty simple why it's not failing. So it actually is failing in, well, it's not true because, no, I guess it is true because we're applying here. But presumably we could print these out, right, just to see that something's going on. All right, so here's the first one. 1, 1. Yep, okay. 1, 2, 3, 4. 1, 2, 3, 4. Leave it alone. 1, 2, 3, 4, 5, 6. Ooh, this didn't work at all. This should have. Oh, wait, maybe this is the last one we have that. No, this is this next one. Wait a minute, where is this guy coming from? 1, 2, 3, 4, 5, 6, 7, 8, 9. Does he not have a 0 anywhere in him? Okay, yeah, he should also be the identity, I guess. Alright, here's a row guy, and here's a column guy, and they both look good to me. Yeah. Here's a row guy, and here's a column guy, and they both look good to me. Okay, so I think the rows and the columns look good. So it's really just, and they print out and they don't fail, so it's really just this guy right here. You're saying I can't be called with just one argument, and I think that's because, so actually I kind of thought it put it in a collection, but I think that's actually right. You actually are just going to get 2 rows. Let's see. Fudge. Don't know how to create iSeq from Java line long. Now we're too far in. Okay. Well, let's just print out row 1 to row 2. R1, R2. Just get a bunch of nils as results. Okay, so it's clearly seeing the values here. R1 and R2. Okay, so if you can see them, then okay, we just need to do some function on them. Like, I feel like min should be fine, but min doesn't take, no, min will also, let's just see what happens. Yeah, min will take R1 and R2 as positional arguments 1 and 2. In the same way that this guy took row 1 and row 2. This one will take value 1 and value 2 from R1 and R2. Oh, I did have one failure still. It also kind of sucks that it just says everything is on line 23, which isn't really true. But anyway, it could be nice if it point to the row, the data that caused the bad data, but 741852963. I feel like this is one I just failed to correct. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're saying you passed in unchanged 1, 2, 3, 4, 5, 6, 7, 8, 9, and you expected to see something different, but that's not right. You should, okay, yeah, you should just expect to see the same thing. All right, so I think that's that, yeah. That zeroes out the rows and the columns from the matrix. Cool. Alrighty, so cool. It basically does it by building out a matrix where the rows have been zeroed out, building out a matrix where the columns have been zeroed out, and then combining the two matrices into one matrix where it defaults to using the 0. On the two values, it'll pick the smaller value. And the only way the value would have changed is if you zeroed it out. Okay. Makes some sense. Alrighty. Oops. Commit. Review 6 edition.